Last week you looked at the strategies for factoring different types of polynomials. This week we want to take the time to put it all together so that when you see any polynomial, you have an idea for how to go through and factor it out. You also need to have the ability to determine whether a polynomial is prime, which means that it cannot be factored. So every time you look at a polynomial, you want to have a consistent routine that you go through to make sure that you take steps to help you to factor it. The first step always is to determine whether there is a GCF. It's important that you factor out a GCF first because some polynomials will look like they're not factorable until you pull the GCF out. And other times the numbers just get so big that by pulling out a GCF you make everything more manageable. So if we look at this polynomial, 8x to the third plus 125, we want to determine whether or not this is factorable. So we look first for a GCF. There is no number that goes into both 8 and 125, and there's only an x in the first term, so there is no GCF. The next question that we have to answer is how many terms do we have? So this is a binomial. So if we're going to factor a binomial, then it's either a difference of perfect squares, a difference of perfect cubes, a sum of perfect cubes, or it's prime. Because this polynomial is a sum, it can't possibly be a difference of perfect squares or a difference of perfect cubes. It's not a difference, it's a sum. And so we want to ask ourselves whether or not this is a sum of perfect cubes. If it's a sum of perfect cubes, then it falls into a formula that we can use. And the question that we really have to ask ourselves is whether or not we can rewrite this polynomial as something cubed plus something cubed. Let's deal with the constant term first. And is it possible that we could rewrite 125 as something cubed? You should have some idea of what the numbers cubed are up to like 6. I'm not going to ask you for something much bigger than that. But 1 cubed is 1, and 2 cubed is 8, and 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. So there we go, we found it. And you can use your calculator to figure that one out also. The next question is whether or not we could rewrite 8x to the third as something cubed. And like we said, 2 cubed is 8. And x cubed is x cubed. So if we were to look at 2x to the third, that would be 8x to the third. Okay. Now we know what a is and we know what b is in our formula. So we can start to fill things in. In this case, a is everything that was cubed to make our first term. So it is 2x. And b is everything that was cubed to make our second term. So it is 5. A squared then is 2x squared minus 2x times 5 plus 5 squared. Okay, we don't want to leave it like this. This is a little unsimplified. And so in order to simplify it, we're just going to go through and clean up the second factor. 2x squared is 4x squared minus 10x plus 25. And now we have our factorization. Now you always want to make sure that you take the time to look and see if maybe there was a GCF that you missed. And in this case, 2x and 5, no GCF there. In the second factor, we have 4, 10, and 25, so there's no number that goes into all of those. And then we need to make sure that this x squared term doesn't factor further. And in this case, it never will. When you have a sum of perfect cubes or a difference of perfect cubes, that polynomial will never factor more. So you can stop there. You should go through the process of checking, and you're going to check it by multiplying it back out and make sure that it does truly simplify to be 8x to the third plus 125. And in this case, it will. If we look at this next example, 3x squared minus 21x plus 36, again, we're going to start the process by looking at whether or not there's a GCF. At the end of this whole process, we have to pull the GCF out. It makes things much easier to pull it out now. 3 times 36, if we start looking at the AC method, is 108. You don't want to go through the process of figuring out what numbers multiply to be 108 and add together to be negative 21. So do yourself a favor and go ahead and pull out that GCF right now. We see that 3 goes into both 3, negative 21, and 36. And so this polynomial, when we pull out that GCF, will simplify to be 3 times x squared minus 7x plus 12. And like with everything else, we always want to check. 3 times x squared is 3x squared. 3 times negative 7x is negative 21x. 3 times 12 is 36. And so our second line is equivalent to our first line. Once we've dealt with that, now we need to work on factoring what's inside the parentheses. The 3 doesn't factor, so we don't have to worry about that, but we need to worry about what's inside the parentheses, the x squared minus 7x plus 12. This is a 3-term polynomial, and so we're going to factor it either by trial and error or using the AC method. Let's go ahead and use the AC method. And in this case, AC is positive 12, right? It's 1 times 12, and that's 12. B in this case is negative 7. So we need to find two numbers that multiply together to be negative 12 that add together to be negative 7. So we know that both of these numbers are going to have to be negative, right? The only way for us to multiply two numbers together and get a positive number is for both numbers to be positive or both numbers to be negative. So in this case, we're looking at negative 1 and negative 12. We're looking at negative 2 and negative 6. We're looking at negative 3 and negative 4. And that's really it. We could continue going, negative 4 and negative 3, negative 6 and negative 2, negative 12, negative 1, but those are all the same number pairs. And so we don't need to go any further. And as we look at this, negative 3 and negative 4 multiply together to be 12 and add together to be negative 7. And so there's our numbers. And we're going to use those two numbers to rewrite what's inside of the parentheses. One thing that you have to make sure that you're careful about is you have to keep writing the 3. If you stop writing the 3, now your polynomial has changed. And once it changes, it's no longer equivalent, and the tendency is to either lose it, stop writing it, or now you're trying to say that things are equal that really aren't equal. And so do yourself a favor and just keep it going from step to step. Okay, we're going to factor this. Now we have a 4-term polynomial. We're going to factor it by grouping. So I'm going to take a look at my first group, and you know what? I'm going to change that parenthesis to a bracket just so it doesn't confuse me and get in the way. In my first group, my GCF is x, and I'm left with x minus 3. And again, I made a decision. I need to check it. X times x is x squared. X times negative 3 is negative 3x. It checks. I'm good. The only thing that I care about now is making sure that what's inside the parentheses matches. That's the only thing that matters. And so I need to make sure that whatever goes on this line, when I multiply it times x minus 3, I get negative 4x plus 12. And so looking at this, it looks like I need that to be negative 4. Right? Negative 4 times x is negative 4x, and negative 4 times negative 3 is positive 12. So that works. Now it's up to you whether you choose to write it like this or like this. It's the same either way. It makes no difference. Factoring by grouping, now I have a 2-term polynomial inside of my brackets. I need to continue to write that 3. The 2-term polynomial inside the brackets still has a GCF, right? That GCF is x minus 3. So I'm going to go ahead and factor that out. I have my x minus 4 there as well. Okay, so we have 3 times x minus 3 times x minus 4. And if I FOIL out the x minus 3 times x minus 4, I get x squared minus 3x minus 4x. There's that negative 7x that I'm looking for. Negative 3 times negative 4 is positive 12. And so that works. Okay. There I am with my finalized factored form. It checks. There's no GCF inside the parentheses, and nothing can be factored any further.